Introduction: a fundamental analytical method used extensively in the dairy sector to measure specific dairy product components based on mass is gravimetric analysis. This process entails transforming the material into a form that permits precise weighing. Gravimetric techniques are frequently employed in dairy analysis to ascertain the fat, moisture, and total solids content of products such as cheese, butter, and milk. For instance, the sample's moisture content can be ascertained by drying it to a consistent weight, but the sample's fat content can be ascertained by digesting it and separating the fat for weighing. The accuracy and dependability of the results the gravimetric analysis yields makes it valuable for making sure that dairy products adhere to food rules and quality standards.
Step-by-step theory. In gravimetric analysis, calcium can be quantified by precipitating it out of solution, then converting it into a stable, weighable compound like calcium oxide through heating. And then, calcium ion in solution are reacted with suitable reagent oxalate ion. Calcium oxalate will precipitate as a solid. And then, filtering and drying the calcium oxalate precipitate is filtered, washed, and dried to remove impurities. Next, the dried precipitate is heated strongly, usually above 500 Celsius, in a crucible to decompose calcium oxalate to calcium oxide. The crucible with calcium oxide is cooled in a desiccator to prevent moisture uptake and weight. From the mass of calcium oxide, the amount of calcium in the original sample can be calculated. Calcium in milk exists mainly as a calcium ion and calcium phosphate complexes. In gravimetric analysis, calcium ion is precipitated as calcium oxalate, then converted into calcium oxide by strong heating. Calcium oxide is stable, non-volatile, and suitable for accurate weighing to determine calcium content.
Next, we move to the methodology. Here are the apparatus and chemical reagents that are needed for this experiment. First, we need beakers with 100 and 250 ml, measuring cylinder, glass rod, dropper, filter paper, funnel, hot plate, desiccator, drying oven, analytical balance, volumetric flask, crucible, and retort stand with clamp. Besides that, chemical reagents, 50 ml of milk sample, nitric acid which has been diluted, 20 ml of 0.1 mol ammonia oxalate, and distilled water. Next, here are the step-by-step explanation about gravimetric analysis. First is sample preparation. Measure 50 ml of milk using a measuring cylinder and pour it into 250 ml beaker. Add a few drops of diluted nitric acid to help break down proteins and release calcium ions. And then gently heat the mixture of the hot plate until it becomes less cloudy and allow the mixture to cool slightly. The second step is precipitation of calcium. Add 20 ml of ammonium oxalate solution slowly to the cool mixture while stirring with a glass rod. A white precipitate of calcium oxalate will form. Then allow the mixture to stand undisturbed for 30 minutes to complete precipitation. Next, the third step is the filtration of precipitate. Set up a filter paper in a funnel into a clean volumetric flask. Filter the mixture to collect the calcium oxalate precipitate on the filter paper and wash the precipitate with small portion of cold distilled water to remove impurities like excess oxalate or acid. The fourth step is the drying of precipitate. Carefully transfer the filter paper with precipitate into a crucible and place it in drying oven at 105 to 120 degrees Celsius and leave it around 1 to 2 hours until it is completely dry. The next steps are cooling and wicking. Once it dries, cool the crucible in a desiccator to prevent it from absorbing moisture from the air. Use an analytical balance to accurately weigh the dried calcium oxalate or called as precipitate and record the mass. Weigh the filter paper first to get the exact mass of precipitate only. Lastly is calculation. Calculate the mass of calcium in the original mix sample using stoichiometric relationship between calcium oxalate and calcium. So for the next slide, we provide a video on how to conduct of this experiment. The next step.
Next, I'm going to explain about how to determine the calcium content in a dairy product milk by using gravimetric analysis through the precipitation and weighing of calcium as calcium oxide. After processing the milk sample, we obtain 0.152 grams of calcium oxide from 50 grams of milk. But we don't actually want to know how much calcium oxide is in the milk, but we want to know how much pure calcium is in there. The gravimetric factor tells us how much calcium is present in every gram of calcium oxide. We calculate it using the molar mass of calcium and calcium oxide. The molar mass of calcium is 40.08 grams per mole, and the molar mass of calcium oxide is 56.08 per mole. So, the formula for gravimetric factor is molar mass of calcium over molar mass of calcium oxide. This gives GF is equal to 40.08 over 56.08, which gives us 0.7145. Now, we just multiply the mass of calcium oxide by the gravimetric factor to find the mass of calcium, which is mass of calcium is equal to mass of calcium oxide multiplied by the gravimetric factor. 0.152 multiplied by 0.7145 is equal to 0.1086 grams. Therefore, from the 50 grams of milk samples, we have 0.1089 grams of calcium. Next, we calculate what percentage of the milk sample is calcium. To do that, we divide the calcium mass by the milk sample mass and multiply by 100, which is 0.1089, divide by 50 and multiply by 100, which will we get 0.217%. Lastly, we are going to calculate the percentage error. If the label on the milk says it contains 0.2% of calcium, we can check how much accurate our result is by calculating the percentage error. So we are going to substitute the value that we get, and then we will get 8.5% of percentage error.
So, for the conclusion, students can accurately determine the calcium content in dairy products, such as milk, by precipitating calcium ions as calcium oxalate and converting it into calcium oxide through strong heating. Students can calculate the exact mass of calcium present in the original sample. The method emphasizes precision in filtration, drying, emission, and weighing steps, showcasing the importance of analytical chemistry techniques in ensuring the nutritional quality and regulatory compliance of dairy products.